Hello everyone, I am Kiara Tanlangit, a first-year student of BS Pharmacy. And in this video, I will be discussing two topics, the mathematics in nature and the sets. Mathematics in nature. So mathematics in nature is a science and mathematics unit that allows students to explore and gain knowledge about mathematical patterns found in nature, such as tessellations and Fibonacci sequence. So there are classification of most common patterns in nature. First is the symmetry. Symmetry is a pattern that shows reflection of images, and the example of this is butterfly. And there are two types of symmetry. First is the bilateral symmetry. Bilateral symmetry is a concept that two opposite sides have identical features. The example is bridge. So second is the radial symmetry. Radial symmetry is a symmetry formed around a central axis. The example is starfish. So the second classification is a fractal. So fractal is a pattern which repeats at progressively smaller sizes and angles. And the example of this is fern. So the third is spiral. Spiral is a pattern that moves around at the central point and continuously widening. So the example of this is a giant wave. Fourth is tessellation. Tessellation is a pattern that repeats figures closely fitting together with. Example of this is the honeycomb. And now we will tackle about the topic sets. So a set is a well-defined collection of objects called the elements or members of the set. A set is represented by a capital letter. So there are two ways to represent a set. First is the roster or tabular form. All elements of the set are listed. The elements are being separated by commas and are enclosed within braces. Example is 1, 2, 3, 4, and 5. Second is set builder form. All elements of a set possess a single common property which is not possessed by an element outside the set. Example is x is a natural number equals k. So types of sets. First is empty set. A set which doesn't contain any element is called empty or null set. Example, let R1 is greater than x and x is greater than 2. X is a natural number. Number 2 is finite and infinite set. A set which is empty or consists of a definite numbers of elements is called finite, otherwise the set is called infinite. Example, let K be the set of the days of the week, and let R be the set of points on a line, then R is infinite. Third is universal set. Universal set is set which contains all objects, including itself. Example, the set of real number would be the universal set of all other sets of number. Fourth is the subset. A set R is said to be a subset of the set K if every element of R is also an element of K. And now we are on operation on sets. First is union. Union of two given sets is the smallest set which contains all of the elements of both sets. Example, let A equals 1 and 2 and B equals 2 and 3. A union B is equal 1 and 2. Union 2 and 3 equals 1, 2, and 3. Second is intersection. Is a subset of each set forming the intersection. Example, let A equals 1, 2, and 3 and B equals 2, 3, 4, and 5. A intersection B is equals 1, 2, 3 and intersection 2, 3, 4, and 5 equals 2 and 3. Third is set difference. The set A to B consists of elements that are in A but not in B. Example, if A equals 1, 2, and 3 and B equals 3 and 5, then A to B is equals 1 and 2. Next is complement. A set of elements in the universal set that is not part of the original set. Example, set U equals 3, 6, 9, and 12 and set A equals 3 and 6, then the complement of set A and A is equals 9 and 12.